Hello everyone, last video I've been demonstrating a program called MicroGo that I've developed in plain C, and the entire source code of the program, just this tiny little 50 lines of code, and it's capable of completing a game of Go. But the problem was how strong it is. It was not strong, and also how big it is. Still, this is quite small, but I wasn't really satisfied with the amount of code being used to come up with some very basic um, things to be done. And I thought that, yeah, probably I have just too huge source code for a program that plays such poor Go. However, my surprise was very big when I realized that GnuGo version 1.2, back from 1995, if I'm not mistaken, is around as strong as my program. It wasn't like initially I needed to adjust something in my program, which I will tell you about. But the amount of source code for the GnuGo version 1.2 was like much more than all the codes I have here. So I'll probably quickly demonstrate what I have within this GnuGo 1.2 version. So you see like a plenty of source files being available here, and all these source files do contain some um, some functions. Okay, so some of them are quite big, and if we go to somewhere like generate move, this is even more. And interestingly here, that since it was just the very beginning of the GnuGo project, the strategy to that computer is applying is very simple and very clear and very well documented. But the amount of code, the amount of code is quite big. And anyway, this is like much more than what I have in my implementation over in here. Another interesting thing that I had no idea that this is the case actually is that GnuGo. The idea of this program is based on the article Programming the Game of Go in Byte Magazine, Volume 6, Number 4, by Jonathan K. Millen. So this is the exact article that I used as the starting point for my program, and I'll even have a tutorial series on how to recreate a program described in this particular article. The program that is called Wally, and that was the implementation of the game of Go on 15 by 15 squares board for an unexpanded key 1, believe it or not. And based on the pseudocode and the ideas described in that article, created a simple Go playing program in Python involving those strategical ideas being presented in the article. So interestingly, the GnuGo takes this over to the next level. Unlikely the original article, GnuGo does it like it may play either white or black, and also it has some minor enhancements. But generally, the overall spirit is very similar to the Wally program from this article. And we'll probably like to show you to read some part from the documentation here. They have quite a fantastic documentation. So this regards to this strategy. This is the strategy. So choose move with maximum value from the followings. Find opponent piece to capture or attack with less than 4 liberties. Then try to save any piece of threatening with less than 4 liberties. Piece means stone. Try to match local play pattern for a new move. No urgent move, then do random move when generating random move bias row and column. So it gives an engine an idea of where to take territory essentially. On third, try take what you get. Done independently for I and j. Invoking count lib to count liberties. If spot already taken of liberties taken, or fill in the I, then reject. If number of retries is greater than max retry, then pass. So this is very simple strategy, and you will now see how this works when GnuGo version 1.2 will be playing against my program. But I need to say that just from the practical perspective, I realized that the amount of code in GnuGo 1.2 is bigger than in my program, and also it feels and it seems a little bit more intelligent than my program. And although my program and GnuGo 1.2 version 1.2 has exactly the same sort of a source of inspiration in its core, the way how the initializers has been developed is changed. So GnuGo does not have any recursive search, while my program is mostly based on recursive search. So what GnuGo does, it does like when it comes to fighting moves, it just statically evaluates groups with by counting liberties, and but it does it with only like one ply depth, so it's not going deeper. It has some sort of a look ahead there in the code. I've seen that, but again, that just like still this is not a real search. Also, GnuGo 1.2 has no idea about what the two eyes actually is. So, although it tries to make two eyes, and it even has a skill trying to invade an opponent's memory and try to make a living group that, believe it or not, which was very annoying for me when I was trying to make my program dealing with that, and it wasn't really that trivial for my program to be able to beat GnuGo. And still, I think they are around even in strength now, so sometimes GnuGo beats my program, sometimes vice versa. So we'll now have a look at a few games. This would be extremely satisfying and fun to watch. So this is like GnuGo is like knowledge, and my program is like search, essentially eninge max search. But what I needed to change in order to make my program beat in GnuGo, well, not all of the time, but some time, hopefully most of the time, is, and maybe just make it full screen, is this part with play away if no forcing moves, the function called tanuki. This is the function. So unlikely the previous implementation where it was just trying to attach one stone to opponent's group, it wasn't really good strategy because first issue was it passed a lot because of the move legality checking got into the conflict with the idea of trying to surround stones. So this time I made it more likely as it is implemented in the original Wally by Jonathan K. Millen from the 80s. So the idea is that now Tanuki function does the following. So, well, the first line, this one, it just tries to apply moves from this opening moves database, essentially trying to take the corners, enclosed corners, take size, and then start expanding towards center. This is very essential kind of thing. This value is essentially made, like I've been tuning these values, adding and removing values to make it possible to be GnuGo. And also another part is apart from this line, the rest of three lines here, they are about engine would try to find the smallest group of opponent stones, and if it has nothing else to do, it would start filling liberties, essentially attacking that group effectively. Also, it might be treated as just making one's territory being complete. That's the side effect, but that works very nicely. And also, I had to go for some hacks. Where is, oh my goodness, where is my I lost this playway. Yeah. I had to add an extra parameter which makes a difference from which side to fill liberties, from the beginning or from the end. Because without this, it was passing a lot. And now one of the most satisfying achievements is that it essentially completes every single game. Well, I hope it would be the case now as well. Okay, in regards to randomization, it doesn't have any randomization, so it will be playing exactly the same game all the time. It has the fixed depth search, the recursive search depth of 6 moves. Sometimes it may get slow, but with GnuGo, usually it's not slow, so it's quite very fast usually. So what else to say? I think this is it, right? So I just want you to have a look at a few games. Yeah, I don't know. Probably I could demonstrate first the idea that I've just described when I try to play a few moves against MicroGo. So probably let's go for this now. I just want to set it as, let's make it a white player, and let's go. So yeah, let me just turn the sound on. Oh, it's not here. Yeah, my cat was sleeping, so I turned the sounds off. Yeah, my cat likes to sleep next to me. So I'm playing dumb moves now, just to give you an idea. So yeah, let's just play some not very dumb moves so far, but so he would be trying to enclose corners. Okay. He would be trying to, again, so all this spot, this spot, this spot, this spot, he would try to take all those spots. Okay. See, like he surrounds me here. Okay. Takes what he can take. So like, it's okay so far. Yes, now he starts this attacking move is quite interesting, yeah. And so he starts like expanding towards the center, and finally, okay, yeah, still the same either. Finally, he takes the center, and from now on, he would start. He would find the group that has the least number of liberties, and would try to surround it. Okay. Since yeah, there is no such a thing, he would probably just consider taking last one. Okay. Okay. I could have played here, and I guess this would be just winning this kind of thing, but I give him a chance. Okay. And I'll probably take this one. Okay. Oh, is he going to capture me into the ladder? This is interesting. Let's have a look. Yeah, he's going to capture me into the ladder. But he gave me a chance to escape. Maybe, yeah, he gave me a chance. Okay. So, yeah, so sometimes it's very dumb, just like GnuGo 1.2 especially. So he is trying to surround the group with the least number of liberties, but this leads to like, essentially getting captured. Okay, so this is like a bit annoying, but even with this glitches, it still can win against GnuGo. And again, GnuGo, since it's very similar in its nature in terms of strategy, it's also vulnerable to this kind of dumb moves. Yeah, so now this group is the smallest group, so we try to escape. Okay, and you see like it's attacking the weakest group, and meanwhile it builds territory, which is quite good. See, it keeps attacking the weakest group. Okay, now it's safe, I'm connected, so I can now go and try to grab something here. Okay. Yeah, so yeah, sometimes it's very, very dumb, like super dumb. Okay. But nevertheless, yeah, just try to want to play away to show. Okay. Yes, still very very dumb. But yeah, it would now hopefully try to switch to another group, or even making a shape move just from the bird search. This is not going to work for him. Oh, but yeah, he's trying to save this kind of group, which is interesting. Yeah, he's trying to save this kind of group. So if I try to escape, yeah. So now this is the smallest group. Okay. If I start attacking him, okay. I want him to fulfill the liberty here. He doesn't yet see that there might be a problem with that stone. He should have considered this one. Yeah, and he considers this one. And I would give him a chance to save this one as well. So, yeah, and he saves this one. Well, obviously, in the real world, you would not be given a chance, but just want to give you an idea in regards of what kind of capabilities it has, which is interesting, yeah. Yeah, this is weird. Yeah, he probably just... I have no idea. He should have tried to save this group. Maybe it's not possible. I don't know. Maybe... I don't know why. This looks so weird. So going to save. Yeah. So it would save later. Yeah, so I don't know why this is happening, but yeah, sometimes it may blunder a huge group for seemingly for the sake of nothing. But well, you know. So yeah, he's pretty much doomed here. I can just essentially take everything here. And yeah, not thinking probably about this group. If I play here, I just capture, I guess. Yeah, I just capture anyway. Nope. Oh, it's not that fast, not that simple yet. Okay. Yeah, it's that anyway. Yeah. So I'll probably try to escape. Okay, let him give that. I want to give him a chance. Okay, give him a chance here. Maybe we'll start attacking me there. So you got the point. You got the idea, and yeah. So interesting. Interesting go. Assuming the amount of code, it's quite interesting go. Is it going to capture me into the ladder? Dun, 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 dun. Maybe not. Maybe not. But yeah, it's not really meant to be played with humans like who know how to play Go. I don't remember. I guess GnuGo 1.2 was rated around 30Q, and some argue that that's a bit too high, so maybe it's even weaker. They are about even level, so well maybe this makes sense to play against this program if you have absolutely no knowledge in Go apart from the rules of the game. In this case, this program has a chance against you. Otherwise, maybe not. Okay, there is no particular sense finishing this game. Yeah, black is just hugely winning, and yeah, essentially I can kill every single group on board. I don't want to do this. So let's better have a look at how engines play in each other. So I've drafted a very basic GTP protocol for GnuGo 1.2, and since it's not very simple, I mean, it's not the matter of being simple. I don't know how to. I didn't want to spend time on making it plain, either white or black, within a single executable. So I just created two executables, one plays with white, another plays with black. So let's kickstart it with GnuGo plays black and MicroGo plays white. Okay, so MicroGo plays white, and I just want to start a new game. And here we go. All right, so you see, like white is building something that looks like an outside influence. Yeah, it gets captured. No, it's not getting captured. Cool. So GnuGo is at this level is also like not very strong. Yeah, eventually, yeah, we'll capture. Although this level, it doesn't seem really that like different either to play with white or black. It's more likely like random kind of stuff because although MicroGo has no randomness in its implementation, GnuGo does have. So they play different games all the time, which is extremely fun to watch. Okay. So I would say that MicroGo is better at local fightings because it calculates 3 moves ahead. So it's good at killing groups. But again, it also happens like quite randomly. Yeah, because it knows nothing about territory. I'm not sure if GnuGo knows something about territory at this level. Probably not. Maybe it does. I don't know. Yeah, probably it doesn't know anything about territory. But sometimes it was like battering an attempt to get territory. Yeah, this game is lost by MicroGo. You see, like this group is going to die, and even if all this would belong to white, this is probably not enough. Especially if black would create a living group in here. Okay, take, please take, please take, come on, please take, please take. Oh my goodness, please take, yeah, okay, great. Now this should be fine. Now this should be fine. Not enough space to make 2 eyes. Unless, yeah. Yeah, okay, gives him a chance. Why gives him a chance? This is so weird. This is so weird. Okay, you see, yeah. So GnuGo is damn good at creating living groups in places where it shouldn't live ever. But MicroGo again has no idea in regards to how things should have been done, like that about territory. No knowledge essentially. Yeah. Okay, hopefully he saved this. At very least he saved this. This is good. This is so good. Yeah, I think this is lost. Every time MicroGo loses to GnuGo 1.2, I feel very like sad. Yeah, I feel very sad. But what I enjoy is that the amount of code is really like smaller and again less knowledge, definitely less knowledge than GnuGo. And also, it does manage to complete the game, which is so nice. So the territory is like almost complete here. It still has something to do, and yeah, like no reason to kill already dead stones, but they have no idea about what the dead stone is. So it's like, yeah, no idea what the dead stone is. MicroGo would try to surround its territories, trying to attach to opponents' groups everywhere it's possible. At least I hope so. I never had a situation in a game where there would be 3 groups. Usually it's like 2 groups. Yeah. Usually it's like only 2 groups. Okay. Yeah, if a miracle happens and white would manage to kill this black and make a living shape. Can you kill 2 stones? Oh! Maybe that's not enough. I guess that's not enough, yeah. That is probably not enough. Yeah, what have you done? It would die anyway, but this is so weird. Yeah, this is probably lost, but still, I want to. I'm still self-testing this. I want to make sure that it plays to the very end. The very end here is when GnuGo fails to generate the move, which is not due to the reason it fails to generate the move, but because the way how I have implemented the GTP protocol for GnuGo is just... Oh, whoa, can you see, guys? Can you see? Oh, MicroGo is about to kill this one. Whoa, this is interesting. Oh, this is so interesting. And it's so... Oh, it's even about to kill this. Whoa, still have a chance. Okay, so yeah, this is where GnuGo is no longer responding. So essentially, it means that it's passing. Yeah, let's have a look at this final score. So white plus 9.5. Essentially, white won the game. Can you believe? Whoa! So I just want to demonstrate. So here it's not showing as white's territory, but here is the deal. So say I just want to... One second. I want to stop engines. I want to detach. Okay. Detach, and so here, let's say black plays the move. Then one takes this. If black tries to save, it would get taken like this. Okay, and then here. So the eventual position should look like something like this. Estimate, yeah, plus 18 essentially, not just plus 9, but plus 18. So that should be the eventual score. Yeah, but the actual result was plus 9.5. So Komi is 7.5, and these are the Chinese rules. So like very close game still, but my program managed to win against GnuGo. Can you believe? Okay, great. Now I want MicroGo to be playing black and GnuGo to be playing white. And let's create a new game. And here we go. Usually it has more chances with black. Yeah, seems like dominating so far. I'm really concerned about the upper left corner here. Yeah, really concerned about that. We're about to lose the corner. Oh man, about to lose the corner, but looks quite promising in the center. Okay. Yeah, and then the invasions would decide the game because GnuGo would try to invade. Okay. Whoa. 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 Yeah. I didn't think that this corner would be taken, yeah. Okay, so now this is totally dominated. The total domination from the perspective of yeah. So it all get decided with these invasions whether they would be successful or not. Okay, yeah, probably successful one. Yeah, unfortunate. So unfortunate. Yeah, and this sequence, yeah, GnuGo is MicroGo is vulnerable sometimes, but yeah, it still kills this one. This is so unfortunate. Okay, he's going to kill this corner. Okay, yeah, he's going to kill the corner. Okay, can you believe? Can you believe? Okay, yeah. So I don't know if this is enough to win the game. I really don't know. I really don't know. Okay, so GnuGo no longer responds, which means it's about to pass. So this is that. Also, this is that. And I'm pretty much confident MicroGo would manage to kill this. Before we have a look at the final score, you just enjoy how the territories has been completed by both sides. So I'm so proud that MicroGo can now complete the game of Go. It was one of the challenges, yeah. Okay, let's have a look at the score. Black plus 1.5. It's still winning. Can you believe? Still winning. Cool. This is really cool. Okay, probably let's have a look at one last game. Yeah, I was saying that GnuGo also is capable of beating my engine. So yeah, maybe it would be the case. Maybe not. I would say that like I played around 10 games maybe. I don't remember the results. Maybe okay. Let's go MicroGo GnuGo white. I've been changing my engine during that process, so it was like many games were lost, but then I made changes. So I didn't play say 10 games with this latest version I'm now using, like with all the fixes. I wasn't doing this. But I think this version was losing. Maybe was it? Maybe it wasn't. I don't know. I don't remember whether this version ever lost to GnuGo. Previous versions did lost to GnuGo by a lot, and that was the case. Okay, again, so MicroGo is playing black, GnuGo is playing white. Yeah, let's go. It would be a different game now, and it's really cool that because of GnuGo has the randomization, games might be different. Okay. One of the differences in evaluation is that for MicroGo, it would start recursive search only in case if the group has less than 3 liberties. So 1 liberty or 2 liberties, it would start recursively search and try to find a move to to save. Yeah, look at this nice kills here. Oh, this is so amazing. So nice kills. Yeah. Is it really going to be better every single time? Yeah, I'm so tempted to know. Maybe it would lose at least one game. Yeah. This sequence sucks really. So yeah, maybe this game is going to be lost essentially. Yeah. Okay. Yeah. Here, GnuGo does quite good. This is dead. Yeah, this is dead, but this is alive because yeah, I also took this for free. Okay. Yeah, this is interesting. Like GnuGo is definitely more intelligent, but MicroGo feels like stronger at fighting. Well, that's reasonable because MicroGo has recursive eninge max search, 6 splice depth. Yeah, so there were a few passes by MicroGo. Okay, and now GnuGo passes. Yeah, although there were a few passes by MicroGo still, yeah, apart maybe this one is completed everything. I just can. So this is that. I just want to show you. I would be so GnuGo is no longer playing. I would try to make some moves for GnuGo. So we just detach this one. Okay, and so this cannot be saved. Oh, hold on a sec. No, this is. Oh, this is alive. No way. Yeah, this is alive. Yeah, this is alive. And say, yeah, I don't want to really spend liberties. Yeah, and now this is passed. Yeah, so now the game is fully completed. So have a look at this score. White plus 44.5. Yeah, so this one is lost by MicroGo. Unfortunately, it's lost. Yeah, maybe let's have a look at one last game with, again, swap the colors. So far, MicroGo won 2 games and lost 1 game. Okay, show engine sidebar. So GnuGo black and MicroGo is going to be white. Okay. So it's quite random sometimes. It's quite random. Yeah, by the way, if this didn't live and if this didn't live, then black would probably win. But yeah, this is go. Obviously, it can be improved even more. But again, I was looking for truly bare minimal program. Okay, so MicroGo is now playing white. And this particular implementation is exactly the bare minimum kind of thing. So obviously, if I start adding some knowledge to it, it would be much stronger than itself, its previous versions, and then GnuGo 1.2. But I'm not interested in going that direction. I'm looking for minimalism. Okay. Yeah, unfortunately, this group is dead. Whoa! Whoa! MicroGo has managed to invade and live. Whoa! This is so promising. Can you believe? Whoa! This is so promising. Yeah. It definitely has a style, you know? It definitely has a style. I quite like that. I quite like that. What are you doing? No way. Yeah, you see, sometimes GnuGo also does this weird thing of trying to crawl along the first line. Yeah, and I hope that this time no invasions are going to work. Yeah, I hope no invasions are going to work now. Yeah, really? Is this the case? Okay. Yeah, kills everything, yeah. Cool. Great. Can you believe? Yeah, and enclosing the territories. Yeah, and GnuGo is passing. It's no longer playing. Oh my goodness. And also, this is alive. Whoa, this is the Crushing Wing estimate. Plus 46.5. Just like this score in the previous game, but reversed. I don't know whether we can claim that it plays better with white or not. It's really hard to say. It depends on many, many things, mostly random things. But anyway, guys, I really hope you enjoyed these games. And now, finally, I can claim that I've made the smallest Go program in existence. No one tried this because it doesn't make sense. And generally, in Go, there's the dilemma of having the huge amount of code which doesn't play well is a very commonly encountered thing. Obviously, I'm talking about Go programming, game of Go programming from like late 80s, early 90s. It's not about this modern neural network stuff. It's not about the Monte Carlo tree search era that was somewhere in between 2000 and 2015, before AlphaGo appeared on stage. So like I was very unsatisfied in the previous video, but this time I'm so happy, very very satisfied, because this is just like this is just great. Yeah, this is just really great, because we have all this kind of thing. We have like program that can complete the game of Go. And yeah, so it won 3 times out of 4, only lost once. Well, again, I think that they are roughly similar. So it's the matter of like, if GnuGo manages to invade corners later, it would most likely be fine. This, maybe I could do something to this, like trying to add some more moves to protect corners in the opening phase. Maybe, but again, this is not that important already. So one last thing I need to do is to probably make the JavaScript version of this program. Not the exact copy of this program in JavaScript, but meaningful names for variables, and it's called BMGP, bare minimum Go program. You can play it in browser. It implements a very simple and basic GUI on its own. And yeah, I just need to work out the Tanuki logic there so that it plays as nicely as this one in terms of completing the game. Yeah. And it's not as deep as this one, so it only calculates for full ply depth because it's JavaScript. But anyway, nevertheless, so still fine. Yeah, guys, this is from my side. Thanks for watching. I really hope you've enjoyed the video because, yeah, I enjoyed making it and I enjoyed playing these 2 engines. So please kindly let me know in the commentaries what do you think about MicroGo. And yeah, and I'll see you in the next video. Until then, and cheers.